Hi, my name is Talia. Welcome if you're new and welcome back if you're not. I'm a recent UCSD alum with a Bachelor's of Science in Chemistry, and I love teaching others about chemistry. This YouTube channel is an extra resource to boost up your chemistry knowledge, whether you're learning these topics for the first time or need a reviewer before a test. In this video, I'm going to be advancing our discussion on KSP calculations and talking about preparing standard solutions using KSP. So if you need help with that, keep on watching, and without further ado, let's get started. So this was an example problem that I did in the previous video, which was the KSP intro. Go ahead and watch that one if you need help with part A of the problem. But I'm going to do a brief refresher. We have a salt, cobalt 2 sulfide, with a KSP of 5.0 times 10 to the negative 22nd. And we solved for the solubility and the concentration of each ion and got that X equals 2.24 times 10 to the negative 11th molar. So part B, or the second bullet point, asks what mass of cobalt 2 sulfide would be dissolved in 1 liter of this solution? What about in 500 milliliters of solution? And what's the concentration of each ion in the 500 milliliters of the solution? So the point of this is to show you that you might need different masses um, depending on the volume of the solution, but the concentration is independent of the volume. Because we're dealing with a salt, that solubility is going to be the same regardless of how much of the solution we have. It's going to be proportionate. So I start by doing our little dissociation equation. Cobalt 2 sulfide dissociates into cobalt 2 plus and S2 minus. Okay, so now that I've done my dissociation equation, I know the concentration of each of the ions um, in equilibrium, and I want to figure out how much of the salt do I need to put into the 1 liter solution. So we do that by multiplying the 2.24 times 10 to the negative 11th by the 1 liter to get 2.24 times 10 to the negative 11th moles. And then I put two equal signs. When you multiply that by the molar mass of cobalt 2 sulfide, you get 2.04 times 10 to the negative 9th grams of cobalt 2 sulfide. So that's for 1 liter of solution. Now, what changes when we have 500 milliliters of solution is that we now have half the amount of moles and therefore half the amount of mass. However, the last part of this question that I guess I didn't explicitly say is that the concentration of each ion in the 500 milliliter solution is still going to be the same because we're starting from that same dissociation equation. As you can see between the two volumes, the dissociation equation is not changing at all. And that is kind of the big idea of this video. It's very short and sweet, but the concentration is independent of the volume of solution when you're dealing with a saturated solution. So that is all for this video. It's honestly kind of an addendum to the previous video that I made on an intro to solubility, just going over the main principle that concentration is independent of volume for a saturated solution. Next time, I'm going to be talking about relative solubility. So it's going to be comparing the solubility of different salts. Feel free to leave any questions or comments in the comment section below, and I will do my best to answer them. Good luck with learning chemistry.